Okay, so we discussed the method of joints. So we have here a Warren truss and we need to compute the forces in each members of the Warren truss. So if you're going to solve in the analysis of structures, of course, you first need to solve for the reactions of the trusses. So in this case, you take a look at the structure as a whole, and then you consider only the external forces. And in this truss, we have three external forces, which are 2,000, 4,000, and 3,000 pounds. So what will be the forces of this point A and point B so that this will be in equilibrium? So we need to find the reaction at A and the reaction at E. So, solving for those reactions, so we have summation of moment at point E. So we take moment at point E and the forces involved will be RA, 2,000, 4,000, and 3,000. So we solve for that. Then we have RA times the moment arm with respect to point E is 20, and that would be equal to 2,000 times 15 plus 4,000 times 10 plus 3,000 times 5, taking the clockwise moment as positive. So in this case, the only force which will have a clockwise effect is RA. The rest will have a counterclockwise effect. So in the principles of statics, the counterclockwise effect or moment should be equal to the clockwise moment for the total moment to be 0. And so we can solve for RA, and that is equals this value, whole value, divided by 20, and we can have 4,250. So how do we solve for RE? Or this is the Y component at E. Okay, so since we have a pin at E, it should have RE, Y component, and Rx. But since in the external forces there is no force which is along the x-axis, it is safe to assume that the reaction, X component reaction at E is equal to 0. And so we only have REY or RE. And solving for that, we get the summation of all forces along Y, and that would be equal to the resultant. The resultant is the sum of all the three external forces, 4,000, 3,000, and 2,000, minus the reaction at A, roller A. So we can have the reaction of E is equals to 4,750. In solving for the method of joints, we consider each pin. We take all the free body diagram of each pin and represent the forces acted upon by these members into the free body diagram. So say for example, we focus our attention at roller A or at this joint A. So the forces that will be involved are the forces RA. The forces of this member, this is AC, and the forces of member AB. So if we are going to draw the free body diagram at joint A, so if this will be this is the free body diagram of joint A, this is point A. This is the force acted upon by AC, the force acted by member AB, and the reaction RA. Okay, so let us solve for the summation of forces along X should be equal to 0 in order for the whole system to be in equilibrium. So if you can see this free body diagram, we can say that this is not in equilibrium because all the forces are acting towards quadrant 1. So let us see. Summation of forces along X is AB cosine 60 plus AC. So we only have two components, and that would mean that AC is equal to negative AB cosine 60. So this means that AC could, instead of being a tensile, so speaking of the tensile and the compressive force, so we assume here in our free body diagram that AC is a tensile force. So it means that the force is acting away from point A. So since our member is here, so it's acting away from point A, so it's a tensile. And we assume also that AB is a tensile, so it's acting away from point A. So, and RA is a compressive force, so it's acting towards that point, towards point A. And so if it's acting towards point A, so we can extend the line of action so that all the tails of the forces should be at this point. Okay, so going back, so we take again the summation of forces along Y, and we have RA plus AB sine 60 is equal to 0. And that would mean that RA is equal to negative AB sine 60. So we can say that RA should not be compressive but should be tensile. However, it would be safe to assume that the direction of the reaction should always be in upward direction. Why? Because if you have an external load here, the tendency of your support is to react an upward direction because of the downward external forces being applied. So that means that instead of RA being the negative value, we say, let's redo this one. So we can say that AB sine 60 is equals to negative RA. And so we have this AB is equals to negative RA over sine 60. And that would mean that instead of AB being the tensile force, AB should be the compressive force. So since this is a negative value, we assume here that AB, based on this free body diagram, we assume that AB is in tensile, and we come up with a negative value. So that means that the direction of the force AB is opposite of what we have assumed. And so the opposite of that, tensile, is a compressive force, and that would mean that the correct free body diagram is this one. This, we consider AC here. So if that would be the case, we have a next component along the left acting towards the left, and X component acting towards the right. And we have an upward RA and then a downward AB. Then we consider this free body diagram as correct. So we solve for A. So at joint A, okay, we solve for A, and at joint A, this is our free body diagram. So having that, our AC should be equal to AB cosine 60, and summation of forces Y should be RA is equals to AB sine 60. And we have solved for RA, and our RA is 4,250 pounds. Then we can say that the force at member AB is equals to RA sine 60 based here, RA divided by sine 60. And so we have 4,250 divided sine 60 is equals to 4,907 pounds. And getting the force of the member AC, we have 4,907 cosine 60. And this is coming from AB cosine 60, and our AB is 4,907. So we have 4,907 cosine 60 is equal to 2,453 pounds. So we now have our AC, AB, and AC, have 2453 pounds. Okay, so the next thing is we select the next point or next joint that we are going to have focus on, so that we can solve for the forces of each members. So here we will select first joint E. Here, joint E. So in using the method of joints, it is much better if we will select the joints at which the reaction occurs, because if that would be the case, we are very sure that the direction of the reaction is correct, and so we can safely assume directions of the forces of each members. So if we are going to take a look at joint E, then the free body diagram of joint E will be, this will be RE, and that's a compressive force. And we have EC, and we assume a tensile force. We assume a tensile force at EC, and supposedly this is right. Okay, so we have RE upward. Okay, so RE having an upward direction, and this is a compressive force towards E. And the next is we assume EC to be intensile. So we have this. And in order for the free body diagram to be in equilibrium, there should have a force somewhere in the lower right. So instead of drawing DE to the quadrant 2, we draw DE at quadrant 4 so that the body will be in equilibrium. And so we now solve for the summation of forces along y-axis, and we have 4,750 equals DE sine 60. So manipulating that one, DE is equal to 4,750 over sine 60. And so we have this equals to 5484.83 pounds. And since this is a positive, so that means that our assumption that DE is compressive force is correct. So DE is equals to 5484 pounds. So the next thing is we get the summation of forces along x-axis. So we just get the summation of forces along the axis because these are all concurrent forces. So having that, we have DE cosine 60 is equal to EC, and that EC is equals to 5484.83 cosine 60, and EC is 2742.41. And so we again have a positive value, so our assumption that EC is tension or tensile force is correct. So we have 2742 pounds. So we have solved for the members involving joint A and joint E. So what's next? So we can select either C, D, or B. Whichever comes first, the answers of the members or the forces of each members should be the same. So in my case, so I choose joint B. So I choose joint B, and having joint B, we have to assume again the direction of this AB and BC. But we have solved earlier that AB is a AB is a compressive. AB is a compressive force. So I should have note that. Okay, so this is 3,000. AB is compressive. AC is tensile. DE is compressive. And EC is tensile. Okay. So, going back here. So, since AB is compressive, then that means that force AB should be acting towards B. And if it's acting towards B, let's extend the line of action of force. And we have AB being in the quadrant 1. And then we have a 200 pounds downward force. And then we have another member here, and that's BD. It's a member BD. So we assume a tensile force at member BD. And by looking at this, we can assume also that member BC is a compressive force. So, okay, so these are all assumptions, but the important thing is that we have solved for the direction of AB earlier. So it should be a compressive force, and this should be the starting assumption of your free body diagram. So if you have assumed differently, then that would produce a negative value for BD and BC, whichever will come, then it should have an opposite in direction if that is a negative value, if we solve for a negative value. So such as this, like this example, so we solved for the summation of forces along x is equal to 0, and that would have as BD, BC, and AB. So we have AB cosine 60 plus BD minus B cosine 60. So we assume here positive force being in the positive force ang AB at BD. So manipulating this one, BC is equals to AB cosine 60 plus BD all over 60. So let's leave this one because we have two unknown. So the next thing is we solve for the summation of forces along y-axis, and that would be equal to 0. And we have AB, BC, and 2,000 pounds. So upward is equals to the downward. So I have AB sine 60 plus BC sine 60 equals to 2,000. And manipulating this one, we can have BC is equals to 2,000 minus 4907. Why 4907? Because we have solved for AB previously. So we already have our value for AB sine 60. And so we can have BC as, we have a negative value. So our assumption here is BD is a tensile force. So that, BC is a compressive force. So that means that if BC is a negative value, it means that this is not a compressive force, rather it is a tensile force. Okay, so next is we solve for BD, and that is BD is equals to BC cosine 60 minus AB cosine 60. So coming from this equation, so we can solve for BD, and we have a negative BC value cosine 60 minus 4907 cosine 60, and they have a negative also, negative 3752.78 BD. And since this is a negative, we assume BD as tensile, so meaning this is not tensile, but this is a compressive force. Okay, so why do we use a negative value for BC? This is because we haven't changed our free body diagram. And using this free body diagram, the values of all the forces that has been solved is a negative value. So since we have a negative value here, so we use a negative value in substituting BC to the second equation. So if ever we are going to change this free body diagram, say we have BC being here and BD being there, so we can use a positive value, but we stick to that. Okay, so next is we select joint D. So selecting joint D, we can have a free body diagram at joint D, and this is joint D. So we have a 3,000 pound force, and then we have members CD, members DE, and members BD. Okay, so since member BD, we already have solved for member BD. Member BD is 3752, and that is a compressive. And we have member BC as tensile, and that is 2598 pounds. Okay, so having that, since we have BD as compressive, then if this is BD, so the force is acting towards there. So we have, this will be the free body diagram, and we have a tensile. Okay, so we only have BD, and then we have CD and DE. So remember that our DE is a compressive, so that's acting towards D. So if that's acting towards D, then the free body diagram will be acting towards D, and extending that we have this DE. So we have two sure assumptions, BD and DE. And in order for this to be in equilibrium, so we can have another assumption, CD, as a compressive force. Okay, solving for this, we take the summation of all the forces Y, and now we can solve for CD is equals to 3,000 minus DE sine 60 over sine 60. So summation of all forces along x-axis should be equal to 0, and we have three forces. So BD plus CD cosine 60 is equals to the left force, which is DE cosine 60, and so CD is equals to DE cosine 60 minus BD. So we can equate these two since we have separated the variable CD or the unknown CD. So we equate this 3,000 DE sine 60 was equal to DE cosine 60 minus BD over cosine 60. Manipulating this one, we can have DE is equal to 3,000 plus BD tangent 60 over 2 sine 60. And so we have D is equals to 5484.83 pounds. So since this is a positive, then that would mean that our assumption is correct. So DE is a compressive force. So DE here is compressive, and that is 5484 pounds. So this is compressive. And solving for CD, we just use this equation. So we have CD is equal to 2020.73 pounds. And since we have a negative value, we assume a compressive force at CD. So that would mean that CD is a tensile force. So CD is 2020, and that is a tensile force. Okay, so we have how many members? 1, 2, 3, 4, 5, 6, 7. And we have solved 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Oh! So we have 8 because we have duplication here, DE and another DE. So okay, so we can actually, okay, actually we can directly solve for CD because we already have the value for DE. But in the assumption that we don't have value for DE, then still we can solve for this. So since they have the same value, then that would mean that whichever point, whichever joint you have selected after solving for E and A, then that is okay. And then, in order to check if these forces of these members are correct, so we can take a look at point C or at joint C. So in free body diagram at joint C, we assume BC. Since BC is tensile, then that's a tensile. CD is, or CD, tensile, and then AC is tensile, and then EC is a tensile. And then we have 4,000 pounds. So solving for that, we have summation of forces along Y. We have this 3, and the upward forces should be equal to the downward forces, and so we have BC sine 60 plus CD sine 60 equals to 4,000. This whole term here should be equal to 4,000, and so retain 4,000, and that is equals to 3999.99, and that is equal to 4,000. So that means that we have a correct assumption of all the forces. And then the summation of forces along X, we have CD cosine 60 plus EC, right? Forces is equal to the left forces. And so we have both this side here should be equal to this side here. And so we have 375 to 0.78, and that is correct. So meaning all our assumptions are correct. That's all.